Hi Math 98. This is a video for lesson 3.7 and so this one, if we were in class doing this or if you were on Zoom, there's a little demonstration that I would do with a logo on a document on the computer. But the way I'm making the videos, I am not able to share my screen during the video. So I'm just going to kind of try to replicate it on the whiteboard. Okay, so what we're talking about in this lesson is proportional reasoning, or having things in proportion. And if you see in the problem situation, it says many professionals such as graphic artists, architects, and engineers work with objects that are enlarged or shrunk. It is usually important that the objects have the same appearance despite the change in size. For example, a business logo on a billboard needs to look the same as a logo on a coffee mug. In this lesson, you will explore the mathematics behind these changes in size. Your instructor will start the lesson with a demonstration. Okay, so what the demonstration is we have some kind of image. In this case, mine during Zoom is a little image that says math on it, but it could be anything. So let's do something simple for my drawing skills here. So let's say that you are going to do a logo for a company, and the logo is just a smiley face. Okay, and as I said, you want to do that logo on billboards, you want to do it on t-shirts for the company, you want to do it on, their notepads, whatever. So it's going to be all different sizes. So if we have this smiley face on a notepad, let's say, and then we put it so the notepad is, like this, and here's my little smiley face up here. Okay, now when I put it on a billboard, which is obviously way, way bigger than the notepad, I still want it to look the same. I don't want it to get stretched out like this, right? That looks totally different than this. It's stretched out, it's wider, it's shrunk, it's not a circle anymore, right? We don't have that when we do this. When a logo gets enlarged, it gets enlarged so it preserves the same shape, right? Just a bigger or a smaller size. Okay, so the demonstration that we do is if you picture copying and pasting an image into a document, like a Microsoft Word document, and then you click on that image, you know that you kind of get these little lines around it, and there's some arrows usually, some kind of little arrows on the sides and on the corners. Okay, so if we pull on just the side, then it would keep the height the same and just make the width wider, and it would kind of pull it so now it does look something like this, kind of distorted. Or in the other direction, if we just pull down, then that would keep my width the same and make my height longer or shorter. I could go up, and so it would distort it this way, right? So obviously those are all smiley faces, but they don't all look the same. Now you might know just from doing other documents that if you pull on the corner, or you pull in on the corner, that then keeps both the height and the width the same. They both change when you do that. So in that case, I would end up with something that's smaller but still the same shape. Or if I pull it out, larger but still the same shape. Okay, so you see the difference between just changing one dimension or the other, or keeping them both together so it's not distorted at all. All right, so that's kind of what the demonstration would have looked like. And while we were doing that, I would have given you some numbers. So in class, if we do this in class, usually I do it and I have someone record the numbers, the sizes of the height and width as we're doing it. This time I just did it ahead of time to make it a little bit easier. So you're going to want to write this down somewhere. We're going to have 3 little charts. So we're going to call it width and height, or you could call it width and length and width, right? Whichever you want to call it. But so width will be this and height will be this. And these are in inches for all of these. That's just the unit I chose when I was looking your document program will tell you what the dimensions are. So 6.5 and 3.15. That's what I started out having my image at. And then, so this is the height, so I'm changing this. I pushed the height up. So it was still 6.5 inches wide, but now it was only 1.43 inches tall. So it's still just as wide, just scrunched it up. And then I did the opposite. Now I pulled it down. So my width again stayed the same, but now my height was 4.17 inches. So again, think about the same width, but we go from having it very short, and then same width tall, and the original was, where we started out. Okay. Then, in the next example, this is where we change the width, but not the height. So again, I would have started out with the same image, and then I changed the width. So now my width is 1.97 inches. My height is still the same. So now I'm going this way, right? First I scrunched it way in, so it's much narrower. Then I'm going to move it out, so it's 8.22 inches and 3.15 inches. Okay, and then finally, the third difference I would make here is where I pull on this corner and the width and the height both change. So again, I start back with my original dimensions, and then I change both of them. I squish it up like this, so now it's narrower and shorter. And then I pull it out, so it's wider. Oh, stop throwing stuff here. Wider than before and taller than before. Okay. So why do we want all these numbers? Well, as we talked about, if I have a certain dimension, okay, it's 6.5 inches wide and 3.15 inches tall. Okay, because as I said, my image that I did was a little logo that said math. So it was, sort of short and wider. If I just change the height, so I push this up, you can tell that it's going to squish those letters. You've played around with images like this before. So these two dimensions together do not make the same look of a picture as these two do. And same thing, if I pull it out, then it's going to stretch out those letters. They're going to look different. So let's take a look at how these are related. So in each case here, let's go ahead and divide width divided by height. Okay, so I'm going to find for each of these my width divided by my height. If you think about when we've done some problems like how many times bigger is such and such than this, like this population density than this, if it's how many times bigger, we divide. So we're just comparing these two now, seeing how they relate to each other. So if I take 6.5 divided by 3.15, I get 2.06. Okay, I just rounded it. So this really means that this is a little more than 2 times as big as that. What if I divide the next two? 6.5 divided by 1.43 is 4.55. This is now 4 times as big as that. It's clearly not going to give us the same shape picture. And if I divide these, I get 1.56. Okay, so their ratio, or the way they compare, is different for each of these pairs of numbers. If I go over here and do the same thing, we know that this is going to be 2.06. I'm starting with the same pair. Let's do the next one. 1.97 divided by 3.15. I get 0.63. Okay, very different comparison. This isn't even as big as this, much less twice as big. And then 8.22 divided by 3.15 is 2.61. So again, the way they compare, the way the width and the height compare to each other is very different for each of these pairs, which makes sense, right? The width and the height of this shape is very different than how the width and the height are connected in this shape. Makes sense. Just can't miss that button. Okay, last one. 6.5 divided by 3.15 is going to be 2.06. We already knew that, huh? How about 0.89 divided by 0.43? 2.0, this rounds to 2.07. 7.29 divided by 3.54 rounds to 2.06. Little bit of a variation in there due to rounding, and you figure also, the computer was rounding these a little bit too. But in general, you can see that the ratio, we call it, or the comparison between these two, in each case is the same. Because even though the widths and the heights change, if I start out like this and then make it bigger but the same shape, that comparison, that ratio between those two is preserved. The ratio is when you are comparing two numbers. Okay. Now, when we have two ratios put together, that's what we call a proportion, which you might remember hearing before. Okay, so a proportion is basically saying, well, if the width to the height here has a certain relationship, then that equals the relationship between the width and the height here. Okay, so I could make a proportion here by saying 6.5 inches over 3.15, so the width and the height of the first image equals the width over the height of the second image, right? They have the same relationship, so they are in proportion. If two things are not in proportion, then they get distorted. If they're in proportion, then they have that same relationship. Okay. So if we were given just the numbers, like if you were given just this table and said, are these images in proportion? Well, you divide each one and see if you get the same thing. So those would be, you could do the same thing here and notice, no, these are definitely not in proportion. All right, so in the next problem, we need to figure out some dimensions that we need. So it says, you are a graphic artist hired to make a billboard for a college. The original logo is 2¼ inches wide So 2¼ inches wide by 3 3/8 inches long. We'll say the height is what they're calling long. So let's make this a little bit bigger. So it's a little bit. So this is 3 3/8 inches. Okay. So we need to enlarge the logo, because obviously I can't put a 2 by 3 inch thing on a billboard, right? So I need to make it bigger without making it look all crazy. I need to enlarge it so it has a length. So this is my length, this is my width. I want the billboard to have a length of 6 feet. I want them to be in proportion. I want to know what that width is going to be. Okay, so we want to set up a proportion like that. I want to say, okay, if these two have a certain relationship, I want these two to have the same relationship. And the thing about a proportion is that I'm going to harp on you over and over and over to put labels on it, to put units on it, to know what you're putting where, because it has to have some kind of pattern. So for example, if I have the width of the small one here and the length of the small one here, then I need to have width of the big one over length of the big one. If it's going to be width to length, it has to be width to length here. Okay. All right, so I'm going to stop this video, see what you can do about setting something up here, okay? And then we'll do that right at the beginning of the next one.